Hello and welcome to Reignite Hope, lesson number 5 in our welding course this semester. So today we're going to talk about a few new things. If you don't have your notebook in front of you, please pause the video, go grab your notebook. We're on lesson number 5. So on lesson number 5, we're going to start off by talking about a couple of electrical terms. We actually talked about them last week, but we're going to talk about amperage and voltage. As I told you before, we don't need to be electricians, but as welders, there's a little bit we need to know about electricity, particularly these two terms here, because they involve what we adjust on our welding machines. And amperage is also expressed in the word current. That's how much electricity is passing through a wire. That's the amperage in a circuit. And then voltage is the pressure inside the wire, if you will, that's pushing those electrons through the wire. And I use the illustration of a water hose, that if you think of turning on the water, the amount of water traveling through the hose would be the current or the amperage, and the pressure that's in there and how far it's shooting out, so to speak, out the other end is the voltage. But what does that mean in terms of welding? Well, in two of our welding processes, the two wire speed processes that we have, we're going to adjust voltage. And then in our TIG welding and our stick welding, we're going to adjust amperage. So amperage would be for TIG and for stick. And then MIG and flux core, we adjust voltage. And so we need to know how that really affects things, and we talked about that last week with MIG. As I increase the voltage, it'll flatten the bead profile. And wire speed is the other adjustment on our wire feed processes here. As I increase the wire speed, that's how we increase the current. With our two wire speed processes, we increase the amount of electricity going into the weld, the amperage going in there by wire speed. And so that would control our penetration. The more wire speed, the more amperage we're getting, the deeper our penetration. But voltage then, with the wire feeds, flattens our bead. More voltage, less voltage, we get more of a rounded contour on our bead. Up here with our non-wire feed processes, the TIG and the stick, we're just adjusting amperage, that's all. And again, that's going to control how deep your bead penetrates into the metal. The voltage actually varies with your arc length, believe it or not. The closer or farther away your stick electrode is, or your tungsten electrode, that actually varies the voltage, but you don't need to worry about that. You just need to keep a nice short, tight arc length, set the amperage right, and you'll be fine. So keep that in mind. That's why those two different variables between the different machines here. And if you know that much, you're going to be in good shape. So now we're going to talk about a couple of other terms there in your notebook, and it's called pushing or pulling the arc. This will apply to all of our welding processes, whether you're stick welding, flux core, MIG, TIG, doesn't matter. You can push or pull the arc, although with TIG you're almost always pushing. But here's what this means. Here's a piece of metal, here's one of our stick electrodes. I could either go in this direction where I'm actually pushing away from myself, I'm pushing the arc as I go along, or I can pull it, going this direction. I could weld like this and I'm actually pulling with my arm versus pushing with my arm. So what difference does that make? Well, a few things. One is that almost every welder is going to end up liking one more than the other. Personally, I like pulling better. It just feels more comfortable to me to pull, but other people like pushing better, and that's fine too. There is, though, another factor in this, is that generally speaking, pulling the arc, pulling will give you a little bit deeper penetration into the metal than pushing will. So if I'm on a really thin piece of metal, I'm worried about going too deep, maybe blowing a hole in it, I might want to push to help me out a little bit with that. On the other hand, if it's something where I want deeper penetration, then I might try pulling to get the bead to be a little bit more penetrated into the metal that I'm welding there. So that's a couple of differences there. Keep in mind too, certain processes, like I said before with TIG, you're almost always going to have to push the arc. You know, you could in some exceptions do it otherwise, but you're almost always pushing with TIG. And if you're MIG welding aluminum, you have to push the arc. It does not work well pulling. So that's a couple of things to keep in mind there. But for the most part, it's going to be a preference on your part. Also, other times you're in some kind of weird position where maybe you like pulling, but you just can't pull where you're having to weld, and you're going to have to push whether you like it or not. There's no pulling available to you, or vice versa. So the position you're in and the particular orientation of what you're trying to weld might dictate whether you have to push or pull. But anyway, that's just helpful information for you to put in your mind there and keep track of that. Practice both of them here in school, because again, when you get out there, sometimes even though you may like pulling like me, you're going to be stuck pushing whether you like it or not sometimes. Also, just another little helpful add-on to what I just said about pushing and pulling, there's kind of a little bit of a saying that if it's got slag, you drag. So the two processes we use that create slag, or that slag coating on top of our bead, are stick welding and flux core welding. And so with those that have slag, you drag, or in other words, you're pulling the arc. You don't always have to do that. There's some leeway on that a little bit, but generally speaking, again, if it's got slag, drag. Okay, the last topic today in our lesson is the basic welding symbol. We're going to cover this for a few weeks, but we're going to get started today. Welders have kind of their own little shorthand way of describing what you're going to do in a weld without having to write everything out. So if a blueprint or an engineer or your supervisor needs to tell you how to do something, they can give you a lot of information just on this thing here called the welding symbol. And you're going to learn a few things about that that'll really help you out. Unfortunately, some welders don't know how to read welding symbols. We don't want that to be the case with you. And knowing how to read welding symbols can really help you out in your career. So here on the board, I've drawn the basic welding symbol here. We have three parts to it. We have something called the tail of the arrow. We've got this line here, this horizontal line that's called the reference line. And then we've got this arrow here. If you look on page 35 in your notebook, you'll see it pictured there. And so we're going to talk a little bit about this for a few minutes. So again, a blueprint or an engineer or whoever can put information below the reference line or above the reference line. And what does it mean by arrow side and other side? It means this. Let's pretend we had a T-joint here. And so this is a T-joint, and we do a fillet weld on this, right? So if it was drawn like this here, any information that's written below the reference line is talking about what I'm going to do on the arrow side. And this is the arrow side because that's where the arrow is pointing. This would be the other side over here. So any information written above the reference line is pertaining to what I'm going to do over here. So for example, I'm going to go ahead and erase that right there. One of the symbols, and I think you'll see that on page 35, is this, and that's the symbol for a fillet weld. But I've written it above the reference line, and that's information talking about the other side from the arrow. So that would mean if I saw that as a welder, if that's all I saw, it means they want me to put a fillet weld on the other side. Now, if that same symbol was below the line, now they're wanting a fillet weld on the arrow side, which is this side where the arrow's pointing. So now I'm going to put a fillet weld over here. If they're both on there like that is, I do a fillet weld on both sides. That's the fillet weld symbol. The main thing to not get mixed up on and keep in mind is stuff below the line is talking about the side the arrow's pointing to. Stuff above the line is pointing or talking about stuff the opposite side of where the arrow's pointing. This symbol here that you see on there, that's the symbol for a groove weld, okay? So that wouldn't apply to our T-joint here, but if you see that symbol, you know that's a groove weld. And in this case, they'd want a groove weld on both sides of the two pieces that you've maybe butt together into a groove formation, okay? We're going to learn several other symbols. That's the two we're going to learn right now, fillet weld and groove. But if you look over on page 34, right next to it there, you're going to see a whole bunch of symbols there. Don't be afraid. I'm not going to make you learn everything on page 34 there, but there are 7 or 8 really common welding symbols that I want you to learn to recognize, and then you'll be in really good shape. Also back here at the arrow, they can sometimes put additional information there. For example, they might write this there. GMAW, we already know that stands for gas metal arc welding. We already know that means MIG welding. So if they put that in the tail, that means they're wanting me to do these fillet welds with MIG, okay? If there's nothing there, then I can choose what I want. I could do a MIG, I could flux cord, I could TIG weld it, whatever. But if the engineer has said, no, I want it MIG welded, and he writes that in the tail, then you know that's the process that you have to use. So that's all we're going to cover today on the welding symbol. Next week we'll go deeper. We're going to talk about some different symbols, so you'll start to recognize other things here like a V-groove weld or a bevel weld and things like that. So like I say, 7 or 8 of them I want you to know, and then you're going to be in really great shape. We'll also maybe put some fractions on here where we're going to talk about leg lengths again. You've learned about leg lengths when it comes to fillet welds. We can show the leg lengths right here on our welding symbol, and we'll talk about that next week.